In the present video, we will discuss the line balancing problem. Let's see the problem. The precedence and time requirements to each element are shown in table. So in the table, there are given the various elements and its precedence elements along with the processing time. The line operates for 7 hours per day and an output of 550 units per day is desired. Then A. Draw precedence diagram for production process. B. Calculate cycle time and theoretical minimum number of workstations required. C. Group the task into minimum number of workstation. So let's see the solution. So there are given the various work elements and its precedence element and the task time are given. Moreover, there are given the total availability time. So there is the given availability time is 7 hours per day. So it is given the availability time is 7 hours and moreover output. So number of units are given the 550 units. First question is draw precedence diagram for production process. For this, observe the table. In the table, first element is element A, and for this element there is the no precedence element. So element A is the starting element. So have to start the precedence diagram with the work element A. So represent the work element A and its task time is 0.65. So next work element is the B. For this, precedence element is the A. So after A, we have to draw the element B like this. And we have to represent its task time, that is the 0.4 minutes. Next element is the C. And it will be start after the element B. So after this one, I have to draw the work element C like this, and we have to represent its task time is 0.3 minutes. Next work element is the D and E. Both these elements start after completion of the work element C, because for the elements D and E, precedence element is the C. So after completion of the element C, we have to draw the work elements D and E. So have to draw the work elements D and E like this and represent its process times are the 0.2 minutes and 0.45 minutes. So next we have to go for the element F. So work element F, it will be start after the completion of D and E work elements. So after completion of the work elements D and E, we have to draw the element F. So like this. And we have to represent its processing time is 0.4 minutes. So next element is the G. So G will be start after completion of the F. So have to represent the work element G like this, and we have to represent the processing time is 0.3 minutes. Next question is calculate cycle time and theoretical minimum number of workstations required. So we know that cycle time C equal to production time divided by required output. Here total availability time per day is the 7 hours. Then production time is the 7 hours. And required output, it is given the number of units are the 550. But here observe, all the elements time is in the minutes. So we have to convert the production time or available time also in the minutes. So it will become so production time is it is given the 7 hours. If we convert the minutes means 7 into 60. So cycle time is production time, that is 7 into 60 divided by number of units 550. So C equal to 420 divided by 550, which is equal to the 0.76 minutes. So next we calculate the number of workstations required. We know number of workstations equal to sum of task times divided by cycle time. So sum of task times are the 0.65 plus 0.4 plus 0.3 plus 0.2 plus 0.45 plus 0.4 plus 0.3, and cycle time is 0.76. Then number of workstations will become the, so total task time will become the 2.7 and cycle time is 0.76, and number of workstation equal to the 2.7 divided by 0.76, which is equal to the 3.55, and nearly its value is 4. So 4 number of workstations are the required. Next question is, group the task into minimum number of workstations. For this, draw the tabular column which consisting of the columns workstation, element, cycle time C, and task time Ti, and ideal time cycle time minus task time, that is the C minus Ti. So first you have to start with the workstation 1, and first element is the work element A. So element is the A, and cycle time for the all the workstations are the 0.76. So cycle time is 0.76, and task time for the element A is the 0.65, and ideal time is the cycle time minus task time of the all the elements in the respected station. So in the workstation 1 there is the only one element, that is A. So ideal time is the 0.76 minus 0.65, which is equal to the 0.11. So element A is completed. So next we will be moved to the element B. So element B will be start after completion of the A. So start the element B, and cycle time is the common for the all the stations. Let's consider 0.76, and the task time for the element B is the 0.4. So here observe, task time is the 0.4, but in the workstation 1 after completion of the element A there is availability time is 0.11 minute only. So in this regard we can't able to add the element B in the first workstation. So we have to close the workstation 1 with the work element of the only one work element, that is the A only. So next we have to start with the element B in the workstation 2. So I have to start the workstation 2. So in the workstation 2, first element is the element B, and cycle time is the 0.76, and task time for the element B is 0.4, and ideal time will become the 0.76 minus 0.4, which is the 0.36. So next element is the, after completion of the B, C, and C will be start after the B only. So next we have to move to the next element C, and cycle time is the same only, so 0.76, and task time for the element C is the 0.3. So task time is 0.3. Here observe, so in the workstation 2 after completion of the work element B availability time is 0.36, and processing time required for the work element C is only 0.3 only. Then we can be add the work element C in the workstation 2. Then ideal time will become the 0.76 minus processing time of the all the elements in the respected workstation. So in the workstation 2, at present we are having the two elements, that is the B and C. So ideal time will become the 0.76 minus of 0.4 plus 0.3, that is the 0.7. So ideal time of the workstation after completion of the B and C elements is the 0.06 minutes. So next we have to move to the next element. Work element is the D. It will be start after completion of the C only. Then we have to start with the element D. Cycle time is the same, 0.76, and the processing time, sorry, task time or processing time is the 0.2 minutes for the work element B. So here observe, in the workstation 2, after completion of the work element C, there is ideal time or availability time is the only 0.06 minutes. But processing time of the element B is the 0.2 minute. In this regard, we can't able to add the element D in the workstation 2. So now we have to close the workstation 2 with the only two elements, that is the B and C. So workstation is, it is consisting of the two elements B and C, and ideal time is 0.06 minute. So next we have to start with the another workstation, that is the third workstation. Third workstation start with the first element is the D. Then cycle time is the 0.76 and task time for the element D is 0.2. Then ideal time will become the 0.76 minus 0.2, which is the 0.56. Okay, next element is the E. So it is also start after completion of the C only. Then we have to add the another element in the third workstation is E, and cycle time is the same, 0.76, and the task time for the element E is the 0.45. So here observe, in the workstation 3, after completion of the element D, there is the availability time is 0.76 and task time for the work element is the 0.45 only. So we can be add the element E in the third workstation. Then ideal time will become the 0.76 minus of 0.2 plus 0.45, which is equal to the 0.76 minus 0.65. Then ideal time equal to the 0.11. Okay, next we will be moved to the next element is the element F. It will be start after completion of the D and E. So D and E is completed, then I have to start the element F. So cycle time is the 0.76 and the task time is the 0.4. So here observe, after completion of the elements D and E in the third workstation, ideal time or availability time is 0.11, but task time for the element F is 0.40 minute. In this regard, we can't able to add the F element in the third workstation. Then now we have to close the workstation 3 with the work elements of the D and E. So third workstation is, elements are consisting of the D and E and ideal time is 0.11 minute. Then you immediately have to start the workstation 4 with the element F. Cycle time is the 0.76 and task time for the element F is the 0.4 and ideal time will become the 0.76 minus 0.4, which is equal to the 0.36. So next element is the element G and it will be start after completion of the F. So F is completed. Then I have to start the element G and cycle time is the 0.76 and the task time for the element G is 0.3 and ideal time is the 0.76 minus of 0.4 plus 0.3, which is the 0.76 minus 0.7, which is the 0.06. Now we completed all the element. Now we have to close the workstation 4 also. So workstation 4 is consisting of the two elements, that is the F and G, and ideal time is the 0.06 minute. So now I have to conclude the group the task into respected workstations. So first workstation is consisting of the elements are the only one element, that is the A, and ideal time is the 0.11 minute. And second workstation is consisting of the two elements, that is the B and C, and ideal time is the 0.06 minute. And third workstation is consisting of the two elements, that is the D and E, and ideal time is the 0.11 minute. And workstation 4 consisting of the work elements F and G, and ideal time is the 0.06 minute. So this is the solution, and thank you.